All right, I think I'm recording now. Okay. So we are actually done with the chapter 7, right? Because the 7.6, this section 7.6, that was the last section in chapter 7. So so the plan, of course, in the next 2 weeks is to finish chapters 8 and 9. Chapters 8 and 9 are kind of short. I mean, there are like 2 or 3 sections in each chapter. So they are kind of short chapters. So I think we're gonna finish everything like in the next 2 weeks. And then if we finish all the material, then we're gonna have more time, I guess, to review everything. All right. So yeah. So the plan today is to. So the plan is to discuss chapter 8. So the first section, chapter 8. So that'll be section 8.1. So yeah, in 8.1, we're gonna try to estimate the population mean when the standard deviation is known. So estimating, this is section 8.1, estimating population mean mu.
Professor, they're writing.
Yeah,
I do not see the board.
You don't see the board?
No.
Anyone else? Do you see the board, guys?
I don't see the board.
Okay.
No, there's no board.
No, I don't see no board. I don't know what the board is.
Okay. All right, there's something going on.
I just logged in and logged out.
All right, okay. What's the problem then? All right, I don't. Okay. All right, I'm gonna just let me see. Okay, I'm gonna. Okay. Oh no, I forgot to share the screen. Oh, sorry. Of course, you cannot see the board. All right, this is like because of the spring break, I guess. Sorry. So I forgot to share the screen, of course. Sorry about that, guys. All right. Okay. Now I'm sharing the screen and I need to go to my app. All right, new project. All right. Do you see the board now?
Yes. Yes. Now we can see.
Okay, perfect. Okay, thank you. All right. So what I was saying, guys, so about the homework. So this is homework 6. So I was saying, so exercises 1 and 2. So they are related to sections 7.3 and 7.5, and then exercises 3 and 4. So they are related to section 7.6. All right. So 7.6. That's actually the last lecture we had before the break. It was April 13th. And as I said, so in the exercise 3 and 4, here the size of the sample is more than 20, so we cannot really use the chart to compute a binomial distribution. Yeah, so you need to check the recording of this section, the lecture on April 13th, so be able to do to solve the problems or exercises 3 and 4. Okay, so again, 3 and 4 in the homework 6, they're about the section 7.6. Okay. All right. Yeah. So I was saying, so this is section 8.1, and it's about estimating population mean mu when sigma, the standard deviation sigma, is known. When sigma is known. All right. So what's the problem here? What's the problem in this section 8.1? So the thing is, in general, it's really hard to find measurements like of the entire population. For example, the population mean. For example, let's say you are in New York and you want to know the average height or the mean height of of all New Yorkers, right? So that's kind of really hard to do, right? To measure the heights of all New Yorkers and take the average, right? So in general, it's very hard to to compute or to find this the population mean or population average, right? So the idea here in this section, we're going to try to estimate instead of measuring this population mean, which is as I said, it's very hard in general. We're going to try to estimate, to make an estimation of the population mean. Okay, so the idea is, so what I was saying is that, so in general, it's very hard. It's hard to, it's hard to find measurements of measurements of the entire population. Okay, so for example, the population mean, mu. The population mean, mu. Okay, for example, you want to find, let's say, you want to find, the population mean or population average height of New Yorkers, right? So, I mean, we're talking about 10 million people, right? That's like a population of 10 million, right? So it's very hard to measure the height of all New Yorkers and take the average, right? That's very hard to do. So the idea is, so that's a kind of impossible, I would say. It's not just hard, it's just impossible. But so the idea is try to estimate. So what we want to do here, we want to try to estimate. So instead of measuring this population average or this population mean, we're going to try to estimate. So we're going to try to estimate the population mean. Population mean mu using samples, okay, based on samples. Okay, so samples, that's very easy to do, right? For example, again, you want to measure the population average height of New Yorkers. Well, instead of measuring like the height of 10 million people, you're gonna just take, I don't know, 100. You can take a sample of 100 New Yorkers or 500 New Yorkers. That's possible to do, right? To measure the height of 100 people. That's possible, right? That's something you can do. So we want to make this estimation of the population mean, and then at the same time, you want to measure of how good is your estimation, right? So you want to at the same time. So at the same time, you want to measure how good we want to measure how good the estimation or the estimate, how good the estimation is. Right? So that's the problem. Here in this section, what we're gonna do, we're gonna assume, or we're gonna suppose that we know the population standard deviation sigma. So the population mean is unknown. So in this section, so first, population mean mu is unknown. Mu is unknown, right? So, and you want to estimate this population mean mu, but we're going to suppose that we the standard deviation sigma, the population standard deviation sigma is known. We're going to suppose population standard deviation sigma is known. So mu is unknown, but sigma is known, right? And we're gonna estimate this population mean mu using samples, right? All right, so the goal here, in this section is to, so we're gonna try to estimate mu, right? The population mu. So what do I mean by estimating the mu, or population mean mu? Well, by estimating, we mean we're gonna try to find an interval, okay? An interval, you know, we're gonna try to find, so the goal here is to find, so we wanna find an interval. Okay, you want to estimate this mu, right? So we're going to try to find an interval, let's say an interval I, says that, right, mu belongs to this interval, I, right? Belongs to I, to the interval. Okay. All right. Now, so this is, we're gonna try to estimate this mu based on samples, right? So we have samples. So we assume, we suppose. So we have a random sample. Let's say we have a random sample. We have a random sample of size n, right? The size of the sample is n, with the average, the sample average x bar is known, with, or sample mean, with sample mean x bar is known. Right. Again, guys, we need to make a difference between the mu and the x bar. So the mu, that's the population mean, or population average, right? And the x bar, that's just this the sample average, or the sample mean. Example again. So for example, the average height of New Yorkers. So population average height, that would be the height of the average of the height of 10 million New Yorkers, right? But for a sample, you can take a sample of, I don't know, for example, of size 100. So you take 100 New Yorkers, and then you measure, you know, the average height of 100 New Yorkers. That's your sample mean, right? That's the sample mean x bar. So of course, there's difference between the population mean. If you take the 10 million New Yorkers and you measure their average height, and you know, if you just take 100 New Yorkers and you measure their average height, right? That will be x bar. So that's different. You're gonna get two different values, right? Now so what we wanna do is you're gonna take the 100, let's say 100 New Yorkers, and you measure their average height x bar, right? And you wanna, you know, estimate the population the population average or the population mean using the X bar, using the average of the 100 New Yorkers, right? So, so we have this random sample of size n with the sample mean X bar, and then we assume, as I said, we suppose that sigma is known. The value of sigma, the standard deviation, the value of the population standard deviation is known. So in the next section, guys, we're going to discuss the case when this sigma, this standard population standard deviation is unknown, right? Because as I said, it's really hard to find measurement of entire population. So it's in real life, it's really hard to find the mu and sigma, okay, or to compute this mu and sigma, okay. So next section, we're going to discuss the case when the sigma is unknown, right? But in this section, we're going to assume sigma is known. So value of standard deviation sigma. This is a population, right? This is a population standard deviation. I'm not talking about the sample. So this is population, the value of the population standard deviation sigma is known. Standard deviation sigma, sigma is known. This is known. Okay. All right. A third hypothesis, third and last hypothesis. You suppose that the variable you have so if the variable x is follows a normal distribution, then the size of the sample can be anything, all right? But if the distribution is not normal, you need, or we require that the size of the sample n to be larger than 30. Okay, so if the distribution is normal, distribution of x is normal, then the size of the sample n can be so n then n can be so n, so that's the size of the sample, and can be any, so it can be equal to any, can be equal to any value. So this works for any sample of size n, any value. But if the distribution is not normal, if the distribution is not normal, distribution of x, of course, is not normal, then we need n to be larger than n. We require n to be larger than 30. And has to be larger than 30. Okay, because otherwise you don't really get a good estimation. Okay. All right. So how can we estimate? So we have this random sample of size n with sample mean x bar. So x bar is known, and you want to estimate the population mean, right? The mu. So all right. So let's see how this works. So how do we? So now the question is, so how do we estimate mu, the population mean, using x bar? X bar, that's the sample, that's the sample mean, right? Using the sample mean x bar, the sample mean x bar, which is supposed to be known, of course, x bar. All right. So the idea is you wanna, your mu, so mu, you wanna estimate mu, right? So you wanna estimate mu. So estimate mu. Okay, so this is equivalent to say that mu belongs to the interval, to some interval around the x bar. Okay, so mu belongs to some interval around x bar. So this is equivalent to say that mu, your population mean mu is in the interval let's say x bar around the x bar. Okay, so close to x bar. So x bar minus, let's say, some number e, and x bar plus e. Okay. So the e here, that's the e here is called the margin of error. Okay, so e. So e, this is called the margin of error. Okay, so again, the idea, guys, is that you have your number line. There's your number line. X bar, right? You have your sample mean. You have your sample. X bar, right? And so what's the interval x bar minus e, x bar plus e? So it's going to be some interval around x bar. Like here, this is x bar minus e, and this is x bar plus e. Okay, and so you want your population mean to. So your population mean mu belongs to this interval around the x bar minus e and x bar plus e. So mu supposed to belong to this interval. Belongs to this interval. Okay. All right. And at the same time, so that's what I mean by estimate mu, right? You want to find an interval to which the mu belong, right? So that would be this interval x bar around the x bar. X bar is no. The sample mean is no, right? So you wanna estimate this mu using the x bar. So it's gonna be an interval around the x bar. So the e here, that's like the as I said, that's like the margin of error, right? And at the same time, you want to measure, you want to have a measure of how good this estimate is, right? And so the question is how good this estimate is. Well, to answer this question, you wanna, in some sense, you wanna measure or you wanna find the probability that your mu belongs to this interval. So this is equivalent to ask what's the probability that, so equivalent to ask what's the probability that mu belongs to this interval, x bar minus e, x bar plus e, or this interval around x bar. So what's the probability that mu, the population mean, which is unknown, belongs to this interval x bar minus e, x bar comma x bar plus e, right? So this probability is, let's say this probability is equal to c, and this number c is called, actually it has a name, and it's called the confidence level. So the probability that, so this is the probability that mu population mean belongs to the interval x bar minus e, x bar plus e. So this probability is equal to some number, and so this number is denoted by c, and this c is, so this is called the confidence. It's called the confidence level. So it's a probability, right? This confidence level, it's a probability. Okay. So for example, And of course, because it's a probability, right? It's between your C is supposed to be between 0% and 100%. But of course, you want your C to be, very close to 100%, right? You want to be 100% sure that your mu, their population mean, belongs to this interval x bar minus E, x bar plus E, right? So we want to C, of course, to be close. You want to C to be close to C. So C is, as I said, C it's a probability, right? It's probability that population mean belongs to this interval around the x bar, right? So we want to C to be close, of course, to 100%. We want to C to be close to 100%, right? Which is 1, of course. For example, let me just give you a numerical example so you can see here what I'm talking about. So for example, let's say C is 95%, okay? For example, let's say your confidence of level C is 95%. So in other words, so if you do, so this is your confidence level. So this is your confidence level. Of course, this is confidence level. So your confidence level, let's say, is 95%. So so in other words, so if you do the experiment, let's say 100 times, do the experiment 100 times, then, at least, or you expect mu, your population mean, to be in this interval at least 95 times, right? So if you do the experiment 100 times, then we expect the mean, population mean mu, then we expect mu to be in this interval, to be in this interval x bar minus E, x bar plus E, 95 times, right? Because your confidence level is 95%, right? Your confidence level is 95%. So out of 100 times, you know that at least 95 times your population mean is going to be in this interval. All right, so that's the confidence level. That's probability that your population mean belongs to this interval, right? Your estimate. All right, so now how to compute this? So now the big question, of course, is how do we compute this interval x bar minus E, x bar plus E? So this interval x bar minus E, x bar plus E, this is called the confidence. It's the confidence interval. So this is just a notation here. So the interval x bar minus E, again, x bar, that's the sample mean, and E, that's the margin of error. And we're gonna see how to compute this margin of error, of course, right? So x bar plus E, this is called the confidence interval. So that's called the C confidence interval of mu. Okay. The C here means that the probability that, so the C, that's your confidence level. So C is, that's the confidence level, and it means the following. It means that the probability that mu is in this interval, x bar minus E, x bar plus E, is equal to C. So it means the probability that mu is in this interval, x bar minus E, x bar plus E, is equal to this number C. to this confidence level C. As I said, we, for example, C can be, for example, 95%. So you are 95% sure that your population mean is in this interval X bar minus E, X bar plus E, right? Okay, now how do we, so now the question, of course, how do we compute this interval, confidence interval, right? So this is now the question. So given a sample of size n, with sample mean X bar known, X bar known, right? So how do we find the C confidence interval of mu? How do you find the C confidence interval of mu? So again, this C confidence interval, that's the X bar minus E, your estimate, right? This is the estimate of mu. All right, so the idea is the following. I'm gonna just try to explain how we get the formula. I don't wanna spend too much time on the details here, but so the idea is the following. So we have your, we wanna mu, right, to be in X bar minus E, X bar plus E. So in other words, you want a mu between X bar minus E and X bar plus E. Okay. You want your population mean to be in this interval between the X bar minus E, X bar plus E. So this is actually equivalent. If you subtract, you can subtract, you know, X bar from your inequality, right? From the first. If you subtract, so let's subtract here. Here I'm gonna just subtract X bar. Okay, so if you subtract minus X bar, so you subtract X bar from the first, the left side, you're gonna get X bar cancel out. So it's gonna be just minus E, and then here it's gonna be population mean mu minus X bar, and the right side you subtract X bar, so then X bar cancel out, so it's gonna be just E, the margin of error. All right. So this is exactly the same thing as mean minus X bar, or X bar minus the mean, population mean, is between minus E and plus E. That's exactly the same thing. That's equivalent, okay? Just multiply by -1 the whole inequality, right? But then I guess this actually probably reminds you of the the formula how to convert X bar to Z. Remember, when we had this the section 7.5. So just here, I'm gonna just recall here in section 7.5. Okay. How to convert X bar, not X, but X bar to Z. And we said, Z is equal to X bar minus mu over, not just sigma, but it was sigma over square root of n, right? The square root of the size of the sample. Okay. Yeah, so this is from section 7.5. So that's how we convert X bar to Z. So I'm gonna do the same thing here. I have the X, so here, as you can see, there is X bar minus mu, right? And that's exactly what I have here in the top, the formula of Z, to convert X bar to Z. In the top, we have exactly X bar minus mu, but then I need to multiply by, I need to divide by this sigma over square root of n, right? So I'm gonna convert this to Z. So convert to Z. So what we're gonna get is, so it's X bar minus mu over, as I said, sigma over square root of n. But then the other side, I'm gonna have, this is minus E times, because I divide by sigma over square root of n, I'm gonna have square root of n here, sigma, and here E times square root of n sigma. Okay. So this would be, here, this would be your Z. So this thing here, that's your Z, right? That's how we convert X bar to Z. Now, the left side and the right side, it's left side here, right side. So this is called, it's called the critical value. So this is, see this minus E square root of n over sigma, and here it's plus E square root of n over sigma. So this thing here has a name. So it's called, so here's your Z. So this thing here, this is called the critical value, Z subscript. So this is minus, of course. So we have minus Z subscript C, the confidence level, right? So Z subscript C, this is called the, so Z subscript C, it's called the critical value. Critical value of C. The right side is the same thing. So this is a plus, right? Because it's a plus. So this is Z subscript C. Okay. So again, this Z subscript C, the critical value of C, this is equal to, so the Z subscript C is equal to the E, the margin of error, times square root of n over sigma. So this is the formula of the critical value of C. Critical value. So in other words, guys, what we are saying here is that critical value of C. So let me just give you the idea here. So the idea is that the probability that, you know, your mu, that mu belongs to, or is in the interval, belongs to the interval X bar minus E, you know, X bar plus E, right? You wanted this to be equal to this C, this confidence level C, right? This is equivalent to say, right? This is equivalent to say that your Z, variable Z, this is the probability that Z, your variable Z is between minus the critical value of C plus the critical value of C. So minus critical value of C plus the critical value of C. So this is actually supposed to be equal to C, same thing here. Both are equal to C, the confidence level C. All right, so all right, so I have this critical value, Z subscript C. So the formula is, there is this margin of error. I don't know yet how to compute this margin of error. I know the size of the sample, N, it's given because I have a sample of size N. So this is known. This is known. Sigma is known, right? And the problem here is this with this margin of error, right? Or so how do you find this margin of error? So the idea is very simple here. There's a, so we have a, you know, there's a table. Let me show you. So we can, to find this critical value, Z subscript C, okay? So we can use table. So the table is in the, let me show you the table. It's in the bottom of, let's see here. So if you go to the table 3, right? Now the second page, right here. So as you can see here, guys, in the bottom, it says table 3 continued. And then you can see there is a confidence interval, critical values, Z subscript C. And then so on the left side, you see there is left level of confidence C. So again, this level of confidence C, it's just a probability, right? That's the probability that mu belongs to your interval X bar minus E, X bar plus E. So for each value of C, of level of confidence C, there is a critical value Z subscript C. So yeah, so we're gonna use this table. This is in the bottom of table 3. You go to the second page on the table 3 in the bottom. So we have this level of confidence C on the left, and on the right you have your critical value C subscript C. So so for example, let me go back to the board here. So the table, this is again in the bottom of the table 3, the second page on table 3. So you see there is level of confidence C, and there is this critical value Z subscript C. And you can see, for example, it says like 0.70 or 70%. The corresponding critical value Z subscript C is 1.04, etc. Right? So for example, for 95%, I want a confidence level of 95%. So that's 0.95 or 95%. Then the critical value Z subscript C would be, so if you check the table, then the critical value of Z subscript C would be 1.96, right? For 95%. All right, so yeah, so what we are saying here, guys, there's this, so we have this formula where, let me write down the formula. So for this critical value, of the critical value. And so then we can deduce the formula for the margin of error. So the margin of error would be, so the formula of E, which is the margin of error. Okay. So, so we have this formula, right? Which relates this margin of error E to the critical value of C. So if you know the critical value of C, then you can solve for E, right? The N and sigma are known. So we can solve for E. So the margin of error E is just equal to, so margin of error E is equal to, so it's a critical value Z subscript C times sigma over square root of N. So that's the formula for your margin of error, right? That's the relation between margin of error and your critical value Z subscript C. So for each confidence level C, you can use your table to find this Z subscript C critical value. And then once you have your Z subscript C, then you can compute your margin of error. And then you can find your confidence interval. All right, so let me give you numerical example, right? So example. All right. So let's say we have a random sample of 40 farming regions. So gave a sample mean price, a sample mean price X bar. So X bar is equal to $6.88 per 100 pounds of oranges. So per 100 pounds of oranges. Okay. And so we have this sample mean price. It's a $6.88 per 100 pounds of oranges. And then we're gonna assume sigma is known. Okay. So we want to estimate, let's say sigma is the population standard deviation is $1.92 but per 100 pounds. Okay. So we want to estimate, or let's say want to find a 90% confidence interval for population mean price. So this is population mean price, mu. So you take the average price of all the farming regions, not just the 40. So here we have the sample of 40 farming regions, right? But your population mean price would be the average price of all the farming regions, right? And let's say in the US. But here we have just this sample of 40 farming regions, right? So we want to find a 90% confidence interval for the population mean price, mu. Population mean price, mu. This is of all. So here population, I mean all the, this is all the farming regions in the US. Okay. So we want to find this population mean price, the average price of all the farming regions of US of 100 pounds of oranges, right? But we took this random sample of 40, right, farming regions. So we have this sample mean price of $6.88, and we assume, right, we suppose that your sigma, your population standard deviation is known, right? It's $1.92. All right, so I want to find this 90% confidence interval for the population mean price. So first, let me just explain what do we mean by, again, by this 90% confidence interval. So I want to find, so I want to try to estimate the population mean price, right? So I want to find an interval around, X bar, the sample mean around X bar, because the X bar is known, that's the sample mean. So find an interval around X bar says that the probability that, the population mean is in this interval, is in the interval X bar minus E, X bar plus E is equal to the C. So the C here, the confidence level is 90%. So this percentage here, I want to find 90% confidence interval. So this is your C. The C is confidence level is 90%. So I want to be sure, like 90% sure that, my population mean belongs to this interval. So here I want the probability that population mean is in this interval is equal to 90%. Okay, that's my, so this 90%, that's my C, that's my confidence level. That's my confidence level. Right, I'm confident, 90% confident that the mean is in this, the population mean is in this interval, X bar minus E, X bar plus E. All right, so the question is to find this confidence interval with confidence level equal to 90%, right? So all you have to do, guys, is to find the confidence interval with confidence level equal to 90%. So find confidence interval with confidence level C equal to 90%. So what's the formula for this? So the answer, the answer is just, it's gonna be the X bar minus E, X bar plus E, okay? Now, X bar is known, right? X bar is given. So the problem is to compute this margin of error, okay, E, right? So all you have to do here is to compute the E. So we need to find the E, the margin of error. So we need to find E. So we need to find, E. E, right? Now what's E? E, the margin of error, we said it's, where is it? It's the critical value, Z subscript C, times sigma over square root of N. So we said this margin of error E is C subscript C, the critical value of C, times, and then we said it's times the, the sigma right here, times sigma over square root of N. So times sigma over square root of N, right? So this margin of error E. All right, so first question is, what's this Z subscript C, right? This critical value with C equal to 90%. So my C is 90%, right? So all I have to do to find this critical value is to use this table, right? We need to go to the table with C equal to 90%, right? So let's go to the table right here, here in the bottom. My level of confidence C is 90%, right? So what's the critical value associated to 90%? As you can see, guys, so we have 0.70, 0.75, 0.80, but we need 0.90 or 90%. And it says the critical value is, you see it, guys? The critical value of the 90%. Does anyone see it from the table? So
Is it,
it's
1.645?
Yeah, it's just the 1.645. Yes. So absolutely. So it's just the 1.645. So right here, so this number, because my confidence level is 90%, so this Z subscript C or critical value is 1.645 to times, and then there is a sigma. It's known, it's given. It's right here. So in this, as I said, in this section, I'm gonna suppose that sigma is known. So it's $1.92, 92 cents. So times 1.92 over square root of N, and of course that's the size of the sample. Here we have the sample of 40 farming regions, right? So the N, the size of the sample, it's 40, right? We have 40 farming regions. So it's over square root of 40. Okay. So this N is just 40. Okay. And yeah. So
Sorry,
that's,
Professor, where did you
Yeah.
get the 40?
oh, the 40 is, it's given. So because it says the 40 is the size of the sample. So because it says we have a random sample of 40 farming regions. So we have a sample of 40 farming regions. So the size of the sample, we have 40 different farming regions.
Okay.
So that's the size of the sample.
Okay.
So like the population, the population here would be all the farming regions in the US, and your sample is just given by 40 farming regions. So you just take sample from all the farming regions of in the US. So yeah, we have 40 farming regions. So the size of the sample is 40. And yeah, and then just, so your margin of error P, it's 1.645 times 1.92 over square root of 40, which is, let me see, let me just check my my notes. Yeah, so it's equal to square root of 40 is 6.324, 332, let's say. All right. And yeah, and then just so E would be equal to, so you multiply on the top, and then you divide by the 6.32, and the answer should be 0.5, I think. So 1.645 times this 1.82, that would be equal to this is like 3.158. Sorry, guys. Over 6.32. So this is, yeah, almost so it's almost 0.5. I mean, if you round your answer here, that would be 0.5. So your margin of error is 0.5. Okay. So to answer the question, so your confidence interval, or the 90% confidence interval, would be X bar minus E, X bar plus E. So let's answer the question. So the confidence, the 90% confidence interval is, so it's X bar minus E, X bar plus E. So X bar, it's given. That's the mean, the sample mean. Where is it? X bar. Yeah, the sample mean price. Sample mean price, X bar, we said it's $6.88, right? X bar is given. So it's 6.88 88 cents minus the margin of error, 0.5. And on the other side, it's 6.88 or $6.88 plus 0.5. So the answer is 7. Where is it? Sorry, 6. This is 6.38, comma 7.38, and that's the answer. So yeah, this is a fine. So this is a fine answer. That's your 90% confidence interval. So all you have to do, guys, as you can see, so confidence interval is given by this X bar minus E, X bar plus E. X bar is known, it's given in the problem. So all we have to do, of course, is to compute this margin of error, E, right? And this margin of error, as we said, well, here's the formula for the margin of error, right? This one right here. Sigma is known, given in the problem. The size of the sample is given in the problem. The only thing you need to check is, or you need to find, is this Z subscript C, or critical value. So this critical value depends on, that's why it's a subscript C, because it depends on C, depends on your confidence level C. And for each, for each value of C, you have a different critical value, Z subscript C. So this depends on C, right? Depends on C. For example, here we had 90%, C is 90%. Then your this Z subscript C is actually 1.645, right? If you want a different confidence level, of course, you're gonna get different critical value, Z subscript C. All right. So what we are saying here, guys, interpretation of the answer. So that's the answer, but so what do we mean by this interval? 6.38, 7.37, 38, 7.38. So what we are saying is we are 90% sure that your population mean price of the 100 pounds of oranges, right, is or belongs to the interval so $6.38 and $7.38. Okay. So it's between, so this average, so mu is between $6.38 and $7.38. So that's what we are saying here. So if you take all the farming regions in the US and you measure the average price of the 100 pounds of oranges, right? Then 90%, you're 90% sure that the average price will be between these two numbers here. Okay. So that's your estimate. You're saying your population mean is going to be between these two numbers. Okay. So all right. Any question so far, guys? So all you have to do in this confidence interval, you have your C, the percentage. For each value of C, you have different critical value. With the critical value, you can compute the margin of error E. And once you have your margin of error E, then the answer, the interval, confidence interval, it's just X bar minus E, X bar plus E. Let me see the chat if there's anything in the chat.
Professor, are we always
yes.
gonna use the 90% for the confidence?
No, that's the thing. So it depends on the problem. So for example, the next, yeah, that's a good point. So like in my next example exercise from the, I'm gonna just take an exercise from the textbook. Let's see. Okay. So if you do exercise 19, page 383. All right, says the following. It says 30 small communities in Connecticut. They gave an average of, so this is your sample, right? So you have this 30 some small communities, right? That's your sample. They gave an average or a sample mean, an average of X bar equal to, so what's X bar? X bar is equal to 138.5 reported cases of larceny per year. Okay. So we have this sample, we have 30 small communities, right? Connecticut. They gave an average of 138.5 reported cases of larceny per year. And then we suppose sigma is known. Sigma is known and is actually equal to, is known, and sigma is, the population standard deviation is 42.6 cases per year. So wanna find the 95% confidence interval for the population mean for the population mean annual number of reported cases reported cases, larceny cases in such communities, right? Larceny cases in such communities. So I guess you take all the small communities in Connecticut, right? And you want to find like the population mean. So that's the population mean annual number of reported larceny cases. So in such communities here. Okay. So as you can see here, guys, the confidence level, it's different. Right? It's not 90%. In the previous example, it was 90%. Here we want a confidence level of 95%. Okay, you want to be sure, like 95% sure that your population mean belongs to your interval. Okay, as I said, you can you want your confidence level to be close to 100%, right? You want to be like 100% sure that your population mean belongs to your interval, right? So of course, if you check the table, as you can see, the confidence levels in the table, well, the highest confidence level, of course, is 99%. I mean, you cannot really be 100% sure of something in general. So yeah, anyway, the highest level here of confidence is 99%, right? But yeah, so your confidence level can be anything from, actually it can be any percentage, because there is a way to find this critical value, Z subscript C. But anyway, like in general, in the homework and the test, the confidence level is going to be from just from this table, right? In this bottom of table 3. All right, so my confidence level is 95%. My C confidence level is 95%. All right, so once you have confidence level, then you can find the critical value, Z subscript C. So for 95%, if you go to the table, 95%, as you can see from the table, critical value would be 1.96, right? 95%, or 0.95, it's 1.96. So this is 1.96. Again, I got this from the table, right? The bottom of table 3. Okay. Once you have your critical value, then you can compute the margin of error E. Okay. Now we can compute the margin of error E. We said margin of error E is Z subscript C, critical value, the 1.96 times sigma over square root of n. So the Z subscript C, the critical value, we said it's 1.96 from the table, times sigma. Sigma is known in this problem. So as I said, in the next section, we're going to discuss the case when sigma is unknown, okay, which is of course harder than when sigma is known. But so yeah, sigma is population standard deviation is 42.6. So here times 42.6, and then divide by, and then you need to divide by the square root of n, right? Square root of the size of the sample. So we have a sample of, this is a sample of, we have 30 small communities, right? So the sample is 30. So over square root of 30. Right. So then let's compute this E, this margin of error. So it just let's see. So let me just let me check my notes. So it's 1.96 times 42.6, which is actually equal to 83. So in the top we have 83.496, if I'm not mistaken, divided by, so square root of 30, so it's equal to this is like 5.47 or 48. Right? And so the answer is point. So let's see my notes. So this is 5.48. Right, so the answer is 15.23, I think. So this is, sorry, this is 5.48, right? This is, so that's your margin of error. Once you have a margin of error, then you are done, right? So then the answer, the confidence, the 95% confidence interval, it's X bar minus E, X bar plus E, right? So it's just X bar minus E, minus the margin of error, X bar plus the margin of error. X bar, that's the sample mean, it's known. We know that this, we have these 30 small communities in Connecticut. They gave an average of X bar reported cases of larceny. It's 138.5, right? That's your X bar, the sample mean or the average mean, the sample mean, right? Or sample average. So what 138.5. So it's 138.5 minus E. That's the 15.23. The other side, it's 138.5 plus the 15.23. Right, so the interval is 95% confidence interval. So it will be 123.27. And the other side, it's 50. So 153 point 73. Right, and that's the answer. So again, what we are saying here is the following. So in other words, so that's the answer. We are done. But what we are saying here, guys, is that so we are right. We are 95% sure that the population mean mu belongs to the interval. It's between 123.27 and comma and 153.73. So in other words, if you take all the small communities in Connecticut, right, and you compute the average, the population average of the of reported cases of larceny per year, then it's between 123.27 and 153.73, right? So again, whenever you have to compute this confidence interval, first you need your confidence level. See, it's given in the problem, right? It says 95 confidence interval or 90% confidence interval or 99, etc. Once you have your confidence level, it's from the problem, then you can use the table to get your critical value Z subscript C. Once you have your Z subscript C, then you can compute their margin of error, right, using this formula. And once you have your margin of error, then you are done, because your interval would be X bar minus E, X bar minus the margin of error, X bar plus the margin of error. Okay. I mean, it's I think it's not really hard, guys. I mean, once you know how it works, then it's, just, of course, you need to apply this. You need this formula right here to compute the margin of error. But once you have your margin of error, then yeah, then you are done. All right. Any questions so far? Let's see. You can do one
Professor?
problem.
Hello?
Yes, please.
My
Yes.
my Wi-Fi
Yeah,
is
I
not
hear you.
working properly. Can you
Okay.
post this lesson soon so I can review it on YouTube?
Yeah, sure. Yeah, sure. No
Please.
problem. Yeah.
So I can
Yeah.
do it throughout, tonight,
I'm gonna.
if
I'm gonna-
possible, or in the morning.
Okay, I'm gonna just grab my lunch, and then probably in 1 hour I will post it on the
Thank you.
recording. Sure, no problem.
Thank you. And if I see anything that I have a question, I'll either email you or See you
Okay.
on Wednesday.
No problem.
Thank you.
All right, guys. Well, we have like just 1 minute left. You know what? We can probably do one more example tomorrow. One more example, and then we're almost done with this section. It's very short, right? And then we can move to the next one. And probably in the next homework, you're gonna have an exercise or two about this confidence interval. All right, guys. I'm gonna stop here, and hopefully, I'm gonna see you tomorrow. Thank you for listening, everyone.
Thank you. Have a good day.
You too.
Thank you.
See you tomorrow. Take care.
See you.
Thank you.